Like if they told me to find the value of y, like the general solution, actually maybe add this in. People forget what this means. This means like find y or like f of x, like your original equation. That's what that means. So like for me, I would probably just like for this one, I would just do like normal antiderivative, like I wouldn't like go too crazy with it, like duh, like you just do a normal antiderivative with the plus c. But like the reason separable equations work is like this is essentially, kind of what you're doing. I think of it as kind of like a cross multiplying kind of thing. So I do like, you'd like cross multiply this, so you'd get dy equals, and then when you cross multiply that, you get 3x plus 1 dx, right? Like if you cross multiplied, and then if you integrate both sides, that's why you have y, and then you have your normal answer. So obviously I wouldn't do this full work just because it's easier to just do straight up antiderivative. But technically you've been doing it the whole time, just not using as many steps essentially. So that's why I like Lebanese notation, no offense to Newton, but like I think it makes more sense when we get to something like this. Okay?
What's Lebanese?
This is Lebanese. dy dx.
Compared to a little I prime.
Yeah, that's Newton. So they all have fought about who discovered calculus. Newton and Lebanese. So it's who you ask. They're in different countries. And who had their proofs first? Lebanese had their proofs first. But more people were using Newton. So he was just popular. Get it? Okay. Anyway, so for this one, we obviously, your y is in there, right? So what you're going to have to do compared to number one, that one's easy, just straight up antiderivative, but because you got y in there, you're going to do separable equations. So I usually put y always on the left just to be safe. That's just my plan. And then equals, and then I'll do this guy. And then integrate. Make sure you put parentheses around that 2x plus 1. Because remember, in old school integration, that's like the height of your rectangle. And then dx is the width. So always put those parentheses there. So now you're just going to take an antiderivative. I'm going to do these colors. So you're going to do y cubed equals, and then x squared plus x, and then plus c. Now, technically there's like a plus c on both sides, right? But then if you add the plus c here, this is a different c, but then you would still subtract it from this c, which still gives you a c. So like, I don't know what the constant is, but like just for simplicity's sake, I like don't deal with the plus c over here, I just deal with this one. Because again, if I did a plus c, this would be plus c1, c2, subtracted over another c. So I don't add c to both sides for that reason, just because I'd be just subtracting constants. So I only put it with the x just to be simple about it, and then now you're just solving for y. So this is like, oops, just disappeared on me, and then that's it. So there's your answer. So you integrate, circle, here we go. So that one's like a nice one, okay? Ones that are kind of sassier are when it's not like straight up cross multiplying, like you got y's kind of like in there. So you don't have to do this every time, but if it makes you feel better, go for it. But like technically, yes, you could still like do your cross multiplying if you need, right? So then this would be kind of goofy because I still got y's and all that junk over there. So you get like 4x. Actually, I don't need parentheses on this, but that's okay. Okay. But then you don't want the y over there because you should only have all dx's on the right side, dy's on the left. So you just have to do a little bit more algebra to throw that y squared over. So you're just going to divide it over. So it's going to be like 1 over y squared dy equals, and then all this stuff, 4x cosine x squared dx, and then integrate. So some of you can do that in your head, like the separating, but like if I was on the AP test and I want to just double, triple check I get it right, I would do all those steps just to be safe. And then now you're going to integrate it. So the left side isn't horrible. What is that? Negative 1 over y, right? Yeah. And then the other side, just keep in mind that like they can make it harder. So like you could do parts, you could do u sub, you could do completing the square, you can do like all the things. So just like keep that in mind. I have seen on BC the parts. I've seen on BC parts. So they can be really mean. So just so you know. This one, I don't think is parts at all though. No, u sub, yeah. All right, thank goodness, right? So I'm gonna let my u be x squared. I don't know how you feel about this, but like there's that 4x up there. This is another way you could do it. You could double both sides. This is like a little fun math trick. Do you know what I mean? So then you're just going to plug the 2 in. So instead of working in the integral, you could work over here before you plug it in. That's an option. So like when I would set it up, then I would get 2 integral cosine u du. Here, maybe. So like this is my u, right? And then this is my 4x dx. You know what I mean? So that's another way you could do it. Or you could just solve for x, you know, and then you would divide by 2. It's kind of what you want. And then now you're going to integrate that side. So you get, so that'd be 2 sine u plus c. Okay. Then I get negative 1 over y equals, and then I'm going to plug the u back in. Okay. All right, now people can get kind of weird with this one. Bless you. So remember, we have no idea what C is. So anything you do to it gets like absorbed in it, if that makes sense. Like, I don't know if C is negative or positive. So like to deal with the negative, I usually, like I'll do negative 2 sine x squared, but I still write plus C. Like you don't say minus C because we don't know what the C is. So I always say plus. And then now I'm going to do a reciprocal. Okay. Is there any questions with that? Okay. Yes? Okay. All right. Next one. This one looks fun. Okay, so again, you can do the full work with the separating, like the cross multiplying and all that stuff. Or you can be like, that's going to be, oops, I want to do red. 1 over y dy equals, and then this beast, 4 sine 2x minus secant squared x over 3. Ew. Dx. Oh, I want that to be green. Oh.
It's fine.
I can't do it. I'm sorry. I can't do it. Okay, now I feel better. Okay, now you're gonna integrate. Okay. All right, so the left side hopefully is easy. Maybe. Natural log. Right? Okay. Now, technically, you would have to do 2 U subs, correct? 2 U substitutions separately. But I think you guys are at our point. If there's a 2x in there, you're going to multiply by 1/2, right, to do the antiderivative. And then if this is a divide by 3, you're going to multiply by 3 for the antiderivative. So for this integral, if you integrate that, that's going to end up being negative cosine. But because of the 4 and the 2, this you're going to multiply by 1/2 for chain rule. And then 1/2 times 4, so that'd be negative 2 cosine 2x. Right? Okay, what's the antiderivative of secant squared? Tangent. Good job. Okay. But because it's x divided by 3, to do the chain rule, you're going to multiply by 3. So it's 3 tangent over 3 plus c. Okay? Okay. So, next what you're going to do is, this is really bad to say, but I don't care, it's fun to say. You're going to E it up. And this is going to be in your entire exponent, which is psycho, but works out. Okay. I keep the bars there. We're going to do, so today is like general solution. Monday will be like initial condition. So I keep the bars there because we're going to deal with that tomorrow. But remember, guys, can we stop the side conversation, please? Remember the, for crying out loud, the exponent rules. What is happening? Oh. Like if you had x squared times x to the third, that's x to the fifth, right? Like you add them, right? So what you're going to do is separate it. So this plus c, remember, if you're using the exponent rules to separate it out, which they expect you to do, it's separated by multiplication. So what this ends up being is negative 2 cosine 2x minus 3 tangent. This exponent is crazy. And then times, not plus, that's what everyone messes up, e to the c. So they expect you to do that and then be like, okay, e to the c is still a constant. Like e squared, e cubed, whatever it is still going to give you a number because it's like 2.7 to whatever power. So then what you're going to do, you're going to throw that c in front. Or I've seen them say a. They like a for whatever reason. I'm going to write it as c. I've seen more c's lately on these tests. And then again, the c can be positive, negative, like with the bars. The c kind of absorbs any like math that's happening to it. So I can go ahead and write it as y. And I can drop the bars. So this one you could see, or a. I've seen p. Ooh. So, yeah. Fun stuff. Okay. Is there any questions where the numbers are coming from? Do you remember this kind? Maybe? No, because the C absorbs it. So like when we have initial condition, then we'll deal with the plus or minus. But otherwise, yeah. This is my favorite one. It looks so cute, right? Do you know what this represents?
Proportional.
Yep, proportional, and it's applied in population. This is general population growth. Okay, general because we'll learn the cool stuff later with carrying capacity. You didn't learn that last year. This year, this is like general population growth. So, when you solve this, you'd have 1 over y dy equals k dx. Okay, rule of thumb, keep your y, like the most stuff away from y as possible. Just because eventually you're going to have to get rid of it anyway, and you're going to have to integrate it then. So keep y as like simple as possible. That's just like my advice to you. So anyway, k is kind of weird, but k is a constant, so we're just going to go with it. Okay, so you get natural log absolute value of y equals, and then this is just kx plus c. Okay. I was sticking with the red and green for a while. All right, we're going to E it up. Oops, what am I doing? Right? Now we know the C is going to absorb all the math to it. Well, I guess I can keep the bars for now. But then again, remember that plus C, they expect you to write it like that. Right? So again, that ends up being like plain C, e to the kx. But again, the bars, like the plus or minus, the C absorbs all the plus or minus or whatever it is. So I'm just going to say it as plain y. And then, do you recognize it? It's PERT. Yeah. Well, it's an R instead of K. That's PERT. Isn't that cool?
Is that why E has to do with like
Growth, yeah. Euler's number.
kind of weird?
Yeah, that's crazy. Yeah.
How they come up
Do
with
you have to show the part so you go from e to the kx plus c to e to the kx times e?
No. I just do that for today just to like, but you can for sure go straight to there. Yeah, I usually do. Yeah, yeah. All right, so why don't you guys separate? Ready, go. Separate.
I did.
Wait, did some of them go to more than one?
Yep.
Oh, that's so sad.
Not all of them have.
You read the description to find out what's why. Yeah, that's enough. That's impossible. What is that? Yeah, I already got my list. Well, you can do subtraction with the sign. Two, you think it's even, in reality it's not. No,